In this segment, we're going to talk about unification. So this is going to formalize what we've seen before in an informal example when we looked at what happened about applying a polymorphic function. So when we have types that contain variables, the unification of two types is the most general common instance of the two. So if you look at this example here, we have a type, a pair A paired with list of char. We have a type int paired with list of B. So in order to get a common instance of that, we're going to have to get a common instance of A and int. So A has to become int. And we also having to get a common instance of list of char and list of B. So B is going to have to become char. So if we substitute int for A and B for char, we get this common instance int paired with list of char. So that's the unification of those two types. So just a few things to say about unification. First of all, the result of unification can be itself a polymorphic type. So take a look at this, a unification of two pairs. The first is A paired with list of A. The second is list of B paired with an arbitrary type. Now, first of all, we have to ensure that A and list of B are unified. That's done by replacing A by list of B. But if we replace list A by list of B, list of A will have to be list of B. Is that compatible with C? Yes, it is. So in fact, we have a common instance here of list of B and list of B. So the two are unified, and that unification is itself a polymorphic type. But you can't always unify two types. Take a look at this example. The type on the left takes an arbitrary type to a list of elements of that type. The type on the right takes a list of integers to a list of integers. So if we look at the first A on the left, that requires A to become list of int. If we look at the second A, that requires A to become int. And A can't become both of those things. So that unification fails. And that can happen, and that can be one of the things that means that a function cannot be applied to an argument. If it's impossible to unify the input type of the function and the type of the argument, that means the function cannot be applied. Now let's just look at function application. We looked at the informal example. Let's state a bit more clearly what goes on here. We have a function type sROT, and we have e, the expression e, having type u. What we need is for u, the type of the expression, to somehow be unifiable, to be compatible with the input type of the function. That is s. So we have to unify s and u. And if we can, giving us a unification, then e will now have the type s prime. We're able to take an instance of sROT, and that means that s prime is now the input type of the function and simultaneously the type of e. So u and s have unified to s prime. But at the same time, we've specialized the output type of the function from t to t prime. Because if you remember, that sounds a bit, the way I'm describing it here sounds a bit abstract, but let me recall what happened when we looked at the example in a previous segment. We unified the type of e with the type of the input type of f, and that required us to replace a by char. So that means in the result type of f, we have the pair bool, comma, char. So as I said in this previous, we apply the substitution, the thing that unified s and u, turning s to s prime, in the case of the example, a to char, we have to apply the same substitution to the result type. And so we get that more specialized result type. But the process of unification goes on between the input type of the function and the type of the argument. So unification is the thing that we have to do when a function application is made. If it's possible to unify, that's the type, and that gives us the type of the result. If it's not possible to unify, then you can't apply the function. So a type error that you will often see from Haskell is fail to unify blah with a blah, which means that it's impossible to apply a function to an argument.